In this lesson, we're going to look at graphing linear inequalities on a coordinate plane. Your essential question is, what are the key ideas in graphing a linear inequality on a coordinate plane? So pause the video, take a moment to write down your essential question, and then restart it when you're ready. In this lesson, we're not going to actually look at a full-blown example. I just want to work through the things that we need to know in order to be successful in graphing it. So the first thing that we need to make sure of is that the inequality must be in slope-intercept form. Okay, and when it's an equation, sometimes we can graph from standard form, but with inequalities, we do need to make sure it's in slope-intercept form. So for example, here's an inequality in slope-intercept form. Okay, we need it in slope-intercept form because we need to understand how y compares to the rest of the equation. Just like with an equation, we would identify the slope, which is 5, and the y-intercept is 2. And so you would start out graphing this by, of course, plotting your y-intercept of 2. And then our slope is 5, or 5 over 1. So we would go up 5, right 1, or down 5, left 1. Now notice I'm not going to connect my points yet at this point, because that's the next step that we need to talk about. So the second thing that we need to know about graphing linear inequalities is we need to know, do we draw a solid line or a dotted line? Okay, and this is similar to when we graph on a number line. Do we put an open circle? Do we put a closed circle? It correlates just the same way. So if we have the symbols greater than or less than, on a number line we would put an open circle. On a coordinate plane we would put a dotted line. And this means that any ordered pair on the line is not a solution. Just like when we put an open circle, we're not going to include those points as part of our solution. And then if we have greater than or equal to or less than or equal to, then we're going to put a solid line. Just like when we do it on a number line, we put a closed circle. It's the same relevance. And just like on a number line, in this case, the ordered pairs on the line are solutions to the inequality. Okay, so we have to have it in slope-intercept form. We have to decide, are we going to connect our points with a solid or dotted line? And then the third thing, just like on a number line, is we need to shade. And we're either going to shade above or below the line in most of the cases. If we have greater than or equal to, obviously we shade above the line. If we have less than or equal to, we shade below the line. Now I want to show you a couple of different examples because we can have a negative sloped line, we can have a positive sloped line, we can have a zero slope line, or we can have a undefined or vertical line. And so every one is a little bit different, and so we really have to think about where is above and below. One little trick that I like to tell my students is think of your lines like stairs. And even if you need to, draw a person where you would walk on the stairs. Now we're not Spider-Man, so I'm not going to draw a person on our vertical line. So if we have a negative sloped line, where you walk is above the line. You can think of it as the sky is up above your head, so this would be considered above. And under your feet, below the stairs, is the ground, and so this is below. Now on a positive slope, it looks a little different. My person is over here. The sky is up above here. This is where I walk, so that is above the line. Under my feet is below the line. It's a little more obvious on a zero slope because it's just flat. This is obviously above, very easy. This is below. And then with a negative slope, with an undefined slope, we really need to think of it more in terms of greater than and less than. So we're thinking, where are my values greater? So this would be considered greater because our numbers are getting larger this way. And then this would be considered less than or smaller because my numbers on the number line get smaller to the left. This should be enough information so that when you come to class tomorrow, we can look at some examples together and put everything together.